In this video, we're going to derive Dr. GB's most favorite equation of all time. No joke, I have only ever considered getting one tattoo, and it's this equation on my back. You think I'm kidding? Nah, you know me. You know I'm definitely not kidding. Either way, I haven't done it because, honesty time, I'm terrified of getting a tattoo. Anyway, why do I love this equation so much? Because it literally tells us how the world works. If this equation comes out negative, the process will happen on its own. If this equation comes out positive, the reaction is going to need a little outside help. Either way, this, not 42, should be the answer to the meaning of life. So let's go ahead and get back to our system. We know that for a reaction to be spontaneous, delta S of the universe has to be greater than 0. And we know that delta S universe is equal to delta S of the system plus delta S of the surroundings. Now again, measuring the universe is tough. So what we can do is we can start subbing stuff in to put the universe in terms of the things we can measure, specifically in terms of the system. For instance, we can substitute in our definition for the definition of delta S surroundings, negative delta H system over T. That gives us delta S universe equals delta S system minus delta H system over T. Great, so we've put our universe in the perspective of our surroundings now. Wonderful, so we've got it as something we can measure. However, we don't like having a denominator in our equation. We want everything to be on our line, one line, and we don't want any fractions. So what we're going to do is we're going to multiply everything by negative t. All right, and so when we multiply everything by negative t, the t's on our delta H system cancel out, and we can rearrange here. We get negative t delta S universe is equal to negative t delta S system plus delta H system. So after this, we know that delta S and delta H on the right-hand side are in terms of our system. So we're going to stop writing system and just assume that. And I'm actually going to go ahead and I'm going to flip that so we have our positive up front, delta H minus T delta S. Now, what we can do here is we can set this portion arbitrarily, set it equal to a new quantity called the free energy, or the G. Now, the formal definition of free energy G is that G is equal to H minus TS. However, we don't measure absolute thermodynamic parameters, we measure changes, so we can represent this as delta G is equal to delta H minus T delta S, all right? And so this is, again, where our delta S is our negative T delta S of the universe. And I've gone ahead and I've written that down there in equation format, like from the word editor, so you have it looking nice, not my scratchy handwriting. So this equation is super valuable because it allows us, because we can measure the enthalpic and entropic changes in a system, and then we can use that to back out the Gibbs free energy of our reaction, from which we can then back out the entropy change of the universe. Now, a big thing to note here is that because delta G is equal to negative T delta S universe, we have the opposite sign of what we may predict. Specifically, a delta G that is less than 0 corresponds to a delta S universe that is greater than 0. So a negative delta G is spontaneous, whereas a positive delta G is non-spontaneous. We learn delta S universe greater than 0 is spontaneous, and we still correlate that positive entropy change with an increase in entropy, but ultimately the bottom line on spontaneity is going to be a negative delta G. The reason